All right, so here's the review walkthrough. 1 through 4, it's asking you to determine whether each relation is a function, right? Yes or no. I'm going to add and why. So give me a reason, like a mathematical reason why we know it is or is not a function. So number 1, we have a table. We are looking at x values, and we have all distinct x values. So this is yes, a function, because there are no repeated x values. Number 2, we have a graph, so we can use the vertical line test. And because if any vertical line drawn through any point on this graph never hits more than 1 point, then this is a function because it passes the vertical line test. Number 3, we have a table again. So we are looking at x values because those are what matter. And there is a repeated x, meaning that this is not a function because x equals -8 repeats, meaning this would not be a function. And then number 4, we would use vertical line test, and we can see that if we draw a vertical line through multiple points on this function, it will hit more than one part of the graph. So this would be no because it fails the vertical line test. Okay, number 5, we're plugging in values and getting the output. What this is essentially asking is what is the y value of the function when x equals 4. So what we're going to do is plug in a 4 wherever we see x. And then solve. So be careful with your order of operations. 4 squared is 16. 16 times 4 is 64 plus 20 minus 2. So 64 plus 20, 84 minus 2 is 82. And we'll do the same thing with -3, always being super careful with our signs. So we get 4 times -3 squared plus 5 times -3 minus 2. So again, order of operations, -3 squared is going to give us +9. 9 times 4 is 36 minus 15 minus 2. So then 36 minus 15 is 21, minus 2 is 19. Okay, and then g of 0, we're going to plug in 0 for all of our x's. 4 times 0 squared plus 5 times 0 minus 2. Those all go away, so g of 0 is -2. All right, same thing down here. We just have a different function. So now we're going to plug in, for letter A, we'll plug in 6 for x. I'm going to go down here. 3 plus 3 times 6 plus 4 over 2. 18, 19, 20, 21, 22. So that simplifies to 11. So 3 plus 11 is 14. Letter B, if we plug in -10, so we'll get this fraction all simplified. 3 times -10, -30 plus 4, -26 over 2. So 3 minus 13 becomes -10. -2, just keep plugging in. -6 plus 4 minus 2. So 3 minus 1 is +2. Okay, and then the last thing is when we have a value in our x, so f of something with a variable, we still plug this in the same way. We're just going to do, instead of plugging in a number, we're going to plug in the whole expression. So 3 plus 3 times, and then there's our x. We're going to plug in 5x plus 4 over 2. And then simplify as much as you can. So this fraction, I cannot simplify at all. So I'm going to leave it like this because it doesn't have anything common that can be factored out or simplified. So my final answer is just going to be 3 plus this fraction that I found when I plugged in the 5x. And we keep these terms separate. We cannot combine the like terms, so we are going to just leave it like this. Okay, sometimes I surprise myself with how easy I make these quizzes. So I have given you the graphs, so you're just going to be able to mostly use the graphs in order to figure out all the pieces of the important points that you're asked for. So if we are looking at this graph, we can see that the zeros occur right there where it hits the x-axis. So we have zeros both at -3 and +3. The y-intercept, we are looking along this axis, and there is nowhere that it intercepts the axis. So we say that there is none. Don't say 0, say that there is none. Then domain, we're going to do this in interval notation. So domain is left to right. We have values from -infinity to that intercept at -3, and then a u because it continues again from +3 to +infinity. So we put brackets at the -3 and +3 because those values are included. And then our range starts low to high, remember, starts at 0 where it intercepts the axis included, and will continue to +infinity. Number 8, the zeros, they look like we can pretty much see them, but when in doubt, remember that we factor to find the zeros. So 3, 2, in order to find the zeros, we take that factored form, set each factor equal to 0, and solve. So we have a 0 at -3 and at -2, which is what it pretty much looks like on the graph. Okay, the y-intercept, again, we can kind of see this on the graph. We can also see it in standard form. So my y-intercept is occurring at +6. And then the domain of this function is from -infinity to infinity. The range, we're going to need to find the vertex of this function in order to figure out the range. It's not super clear, so we need to find it, and it's going to be ugly because it's fractions. It's going to get gross, but you can do fractions. So we have standard form. Remember that we can find the x-coordinate of our vertex, -b/2a, -5/2. That's the x-coordinate of our vertex. To find the y-coordinate of our vertex, we plug this x in back to that equation. So for y, we will say y equals our x-coordinate, right? Plug it back into the original, squared plus 5 times x plus 6. So -5 squared becomes 25/4 plus, actually this is going to be minus 25/2 plus 6. I'm going to get a common denominator for everything so that I can add and subtract all these together. So 4 will be our common denominator, minus 50/4 plus 24/4. So if I do 25 minus 50 plus 24, sorry, 24 minus 50 plus 24, I get -2. Okay, it was 25. 20. So wondering why it came out so neat. So 25 stays the same. So 25 minus 50. 25 minus 50 plus 24. So that just leaves us with -1/4. So the y-coordinate of our vertex is -1/4, meaning our range starts at -1/4 and will continue to +infinity. All right, last one. Okay, the zeros of this function, you can find the zeros of this function. I'll do it algebraically as well, but we can also see them on graph. So there's a 0 at -4, -2, and at 0. The way we can find them is by factoring. If we want to do it algebraically, which would be always fantastic, pull out an x from every term, and then we can factor what's left in here. So 4 and 2, so we get x plus 4 x plus 2. Set each of these equal to 0 and solve. So we've got one at 0, one at -4, one at -2. So like multiple ways to do this, especially if you can't really see it on the graph. All right, y-intercept is occurring at our, we can see it on the graph. It's going through the origin at 0. The other way we can solve for y-intercept is that it occurs when x equals 0. So plug in a 0 for every x, which is going to just get us that y equals 0. The domain of this function left to right is coming from -infinity and continuing to -infinity with no stop. The range also, it's coming from -infinity and continuing to in positive infinity, low to high. So that's it. That's essentially what you need to be able to do on this test is, plug in values in functions and then talk to me about key points on functions.